This is video number 1 for section 3.6, Graphing Linear Inequalities. Remember, we're in this portion of the chapter where we are revisiting some things we've done before, but substituting the equals sign with symbols like less than or greater than or equal to, etc. This lesson is a very visual lesson. You can see that first example there is asking us to draw a graph. We're being asked to graph y is greater than or equal to 2x minus 1. Now let's think about that for a minute. We already know how to graph y equals 2x minus 1. That's just a line. We've done that for a long time. That's clearly part of this answer. So let's begin there. First, we need a set of axes. And then to make our line, the y-intercept is -1, so we'll start there. And then the slope is 2, so I need to, from the y-intercept, travel up 2 and over 1. And then again, up 2 and over 1. And then connect the dots and I'll have my line. That line is the line y equals 2x minus 1. All right, now to finish off the picture, what I need to realize is that for every x on this graph, I'm not just interested in the y value that's equal to 2x minus 1. I want all the y's that are bigger as well. For example, take a look at x equals 1. 2 times 1 minus 1 is 1. That's why we have the point 1 comma 1. But then for that x, I also want all the y's that are bigger. But then the same thing for x equals 2. I want all the y's that are bigger. And for all the x's, this is true. And so by the time I'm done, this entire region is going to be filled in. The final picture, the final graph here is essentially half of the xy plane. That line serves as a bit of a border, and then everything above it is shaded. Well, once you do this once, you can really boil this process down to a simple series of steps. I've tried to summarize it for you in this box. Step 1 each time is to go ahead and graph that border line. Now, the way you do that is by pretending that the original problem simply had an equals sign. Now, one thing to note, in our problem, we had a greater than or equal, and so we made our line solid because the line itself is part of the solution. In a future problem, if we only have a less than or a greater than, then the line itself is not part of the answer, and so we make it dashed to show that. Step 2 is to figure out which side to shade. You'll always just be shading one side or the other. Well, it's very simple. You simply shade above if you have a greater or a greater than or equal to, if its y is greater than mx plus b, and you shade below for y is less than mx plus b. Now, this only works if your inequality is in the good format, the y equals mx plus b format, so keep that in mind. Step 3 says you can check your work by using what's called a test point. Let me demonstrate that for you on this last example. The idea is simply to go back up to your picture and choose any point on one side or the other of the line. Don't pick a point on the line. It has to be on one side or the other. How about this point 2, 0? What I will do now is I will test that point out. That means take it and plug it back into the original inequality. Now, if you picked a point on the unshaded side, then it should not make that statement true. Well, let's plug it in and see what happens. I'd be plugging in 0 for the y and 2 for the x, and I work out the math. 4 take away 1, 3. Is 0 greater than or equal to 3? No, it is not. That's false. Well, that's good. That's what I wanted to happen. That means that 2, 0 isn't a part of the solution, and that's exactly what I drew. That gives me confidence that we shaded the correct side. Let's now try a fresh example. I've got this second example here. Graph 2x minus 3y is greater than negative 3. Now, maybe you're looking at that example and thinking, well, we're going to be shading above because I can see that greater than. Well, not so fast. Remember, that step only works if your inequality is in the good format. This one isn't. I need to put it in the good format first. So to get y by itself, it looks like I'll need to subtract 2x from both sides. And then I need to divide both sides by negative 3. And you can probably see where this is headed. Remember, with an inequality, when you divide both sides by a negative number, you have to flip around the direction of the inequality symbol. So this is going to become y is less than 2/3 x plus 1, it looks like, after I distribute. That's now the inequality that I will seek to draw. Let's go ahead and give ourselves some axes. This time my y-intercept is positive 1. And then my slope is 2/3, so up 2 and over 3. And when I connect the dots, I have to remember that the original problem does not have an or equals to. That means the line itself is not part of the answer, so I need to connect the dots with a dashed line. All right, and then I just need to decide which side to shade. Well, it's very simple. My inequality is in the good format. It's got a less than. That means shade everything below. And so the final solution to the problem looks like this. Remember, all we're saying here is that the points we're coloring in, the XY points we're coloring in, those are the ones that would make the original inequality true. Let's finish this off by choosing a test point. You know, often a very, very simple test point to pick is 0, 0, because the numbers are so easy. You can't pick that one if it's on the line, but in our case, 0, 0 isn't on the line. Remember, what you need to do is you need to plug that test point back up in the original inequality. Don't plug it in anywhere else, otherwise you may not catch a mistake that you've made. So I need to plug 0, 0 into 2x minus 3y is bigger than negative 3. That's going to become 2 times 0 minus 3 times 0 bigger than negative 3. I'm just trying to figure out if this is true or false. It looks like the entire left side is just 0. I end up with 0 is bigger than negative 3. That is a true statement, and that's good. That's what I wanted to happen because 0, 0 is in the section that we shaded. So it's good that it came out to be true. This gives me confidence that I did the problem correctly. Let's work one more quick example. This is the only one that's perhaps a little bit strange. This one says graph the inequality x is less than or equal to 2. Well, step one, I start with my border line. My border line would just be x equals 2. That's a vertical line. Let's start there. Here's a set of axes. My border line is simply the vertical line x equals 2. Should I make it solid or dashed? Well, I go back to the problem. The equal sign is there, so I should be making it solid. Now I have to decide which side to shade. Well, this is where step 2 has to be tweaked just a little bit. Vertical lines are the only ones where I can't shade above or below. I can only shade left or right. And I don't think it's difficult to understand that if you have a less than, you're going to be shading to the left, and if you have a greater than, you're going to be shading to the right. In our case, we want all x's less than 2. Well, those are going to be found over here to the left, and so that's where we'll shade. Here then becomes our final answer, all of the points on the vertical line and to the left. Once again, we could choose a test point. This is a pretty simple example. I could go with 0, 0 again, and I would be expecting this to come out true because 0, 0 is in the part we shaded. Remember, you take your test point, you go back to the original inequality, you plug in your x and y, although for us, I only have an x to plug in. Is 0 less than or equal to 2? Yes, it is. That's a true statement, and that's good because 0, 0 is on the side that we shaded.